Hello everyone. In this video we'll talk about LDA, which is nothing but linear discriminant analysis. So LDA is mainly used for the classification problem, right? So first we'll try to understand why we need to use LDA, even if we have few other classification algorithms like logistic regression, so on, right? So we know we have two class problem, right? So logistic regression is mainly intent for two class, which is nothing but binary classification problem, right? We can also use logistic regression for multi-class problem, but it is rarely used for that purpose. So I'm repeating myself again. Logistic regression can also be used for multi-class, which is more than two class, but that is rarely used. So logistic regression is mainly used if you have a binary problem, which is two class, right? Unstable with well separated clusters. So logistic regression can become unstable when the classes are well separated, right? So unstable with a few examples. Let's say if I have only limited data to train my model, obviously, right? So when you want to train your model, you should have some decent amount of data, right? The good amount of data. Then only when you talk about the logistic regression, right, it can find a best parameters, right? When you talk about parameters for the logistic regression, it's nothing but your slope, constant, or beta, error, etc., right? So it obviously needs some good amount of data, right? So to overcome the above problem, we can use linear discriminant analysis algorithm, which uses probability. So we might not have a problem related to the uneven classes, low number of data, right? So less number of records, whatever. So this LDA also used for dimension reduction, right? So LDA can be used for the classification, and it also can be used for the dimension reduction. So dimension reduction is one of the major topic in data science and stats world, but here in this video we'll talk about LDA for classification. So now we'll jump into Excel, right, and we'll see the data. This is a sample data we are going to use for our LDA calculation. So we have almost 20 columns with balanced class, which means so I have 10 records which belongs to 0 and the remaining 10 belongs to 1. So we have two types of data, right? One is balanced data or balanced class or imbalanced class, right? So if you're not aware about that, so I made one video, so please go and watch that video for more understanding, right? So and this is the formula, right, for the discriminant, right, for LDA for classification. And if you see the formula, right, it's very straightforward. We know what to find, right? We need to find the mean, variance, and the probability. But it's not that straightforward, like calculate the mean, variance. It is straightforward, but the way we need to do is little bit different, which we'll do it now. So we know mean, variance, right, and probability. So if you're not sure, please make sure watch my previous video. I'll put the those links in the description, right? So first what we'll do is we'll try to find the mean. Mean we know, right? So sum of all the values divided by total number of values, right? But here in this case I need to find the mean for 0, right, and the mean for 1. Similar way I need to find the variance for 0 separately, and I need to find the variance for the variance for y equal to 0, the variance for x when y equal to 0, the variance of x when y equal to 1. In the similar way we have to find the mean of x when the variance of y equal to 0 and the mean of x when y equal to 1, right? So I already let me get the data. So first I am copying the data that belongs to 0 class 0. Okay, so let me paste it here. What's wrong? Just a second. Yeah, let me paste it. Yes, so this is value of x when y equal to 0. So obviously we need to find the mean. Sorry, it is in Excel, it is average. Now this is 4.9, this is mean, and we need to have variance, right? So variance for sample, yeah. So similarly I need to find the mean and variance of x when y equal to 1. Average, yeah, no, variance yeah. So now we find the mean and variance for x when y equal to 0 and when y equal to 1, right? So we have these values. This is x when y equal to 1. So I'm not sure if I can copy and paste it here. Let me try again. Yeah, oops, okay, yeah, because this is formula, right? So 20.08706, right? So it's 20.087 20.08706, and what is the mean? 1.13122. 1.13122. And now I need the values of x when y equal to 0, mean, variance. So mean of x when y equal to 0 is 4.9754. 4.9754 4.57 975416. Come on, I know it is difficult. And its 0 variance is 534644. 534644. It's 0 point. Yeah. Now what we need to do is, so now we need to find the average of the average of the variance when y equal to 1 and y equal to 0, right? So which is variance average equal to, right? Let me, okay, yeah, sorry, is equal to this variance plus this variance divided by the degree of freedom. So here the degree of freedom is number of rows minus number of class, which means we have almost 40 columns, right? So 20 columns are 0, sorry, 20 rows, right? So which means we have 40 rows, we have 40 data points. So out of 40, 20 rows are zeros and 20 rows are 1. So which is, and we have two classes, right? So which means 40 minus 2, which is 1.14, right? We'll check if it is correct or not. Maybe, well, for the safer side, we'll put the brackets. It would be the same. Oh no, what's wrong? Yeah, this is right. Yeah. So now, and now we find the variance, right? We also find the mean for the respective when y equal to 1 and y equal to 0. Now we need to find the probability. So the probability of y equal to 0 and the probability of y equal to 1, right? So we also need to find it. So now it will be something like this, right? Discriminant, maybe I'll just write simply LDA of y equal to 0 of x. This is what I want to find. I'm really sorry, it is just y equal to 0. My bad. Yeah, this is not this LDA, it should be probability, right? So you can also see capital P, you can also write abstract capital P, right? So probability of, come on man, y is equal to 0. We know, right? So count of y is equal to 0 divided by count of y equal to 0 plus count of y equal to 1, right? So So obviously, right, so we'll get 0.5 both in case of probability of y equal to 0 and probability of y equal to 1. Why? We have equal classes, right? If we don't have equal classes or balanced data, right? In case if we don't have equal classes, which is imbalanced data, then obviously the probability of y equal to 0 and y equal to 1 will be different. I already have a screenshot of it. Let me paste it here. Yeah, this is so probability of y equal to 0 when y equal to 0, so count of y equal to 0 by count of y equal to 0 plus count of y equal to 1. We know, right? So count of y equal to 0 is 20, right? And we total have 40 records, so 20 by 40 is 0.5. obviously again when y equal to 1 is the same case, right? So now I think we have enough thing to derive our equation. We have a mean, we have a variance, and we have a probability. Now what we'll do is, now we'll take some data. So I'll say when x equal to maybe 4.667798, some random value. Now this is a new value, right? Now I need to tell, using LDA, I need to tell this value belongs to which class, whether it belongs to 0 or whether it belongs to 1, right? That is what we want to identify now. Now let's do it, right? Now the LDA of y equal to 0 of x. So now what we need to do? We need to substitute these values in this formula. We know what is x, right? Which is 4 is equal to 4.667798 into, what is that? Mean by variance. So now I said y equal to 0, which means I need to take the mean of when y equal to 0, which is 4.975416, right? Now what else? Divided by the variance. This time when I say variance, it's variance not the value when y equal to 1 and y equal to 0. So we already calculate the average of the variance. We have to take that value, right? And this is the value, right? And then what I need to do? I need to subtract with the mean square. What is our mean when x equal to 0, which is this. Maybe I'll put in the brackets this whole to the square of 2 divided by 2 into variance. This is our variance, we know, right? Now this is the value. Now obviously I need to add with my probability, right? So which is 0.4. At last we have a probability, right? So this plus 0.5, this is my value when y equal to 0. Now similarly I need to find for y equal to 1. Same, so I need to do 4.667798 into, what is my mean when y equal to 1? It is 20, right? Okay, I did not set the equal to here. My y equal to 1, my mean is this, divided my variance minus mean square. Oops. My mean is obviously y equal to 1 is 20 whole square 2. Sorry, array, come on man, why are you so hurry? Whole square divided by 2 into my variance, right? And this is the value, so I need to add with my probability, which is 0.5. Now if you see here, right, so here I can say, right, so I can say this value of x 4.667798 belongs to 1, belongs to class 1, because if you see the value, right, so obviously how I need to take is whichever the value is greater, then this value belongs to that particular class. Now if you see, it is like when y equal to 0 is minus, it's a negative, right, and x when y equal to 1 is a positive. So we can conclude, hey boss, so this 4.667798 belongs to class 1, right? So this is how the linear discriminant analysis works, right? So let's say, if we have multiple variables, right? So now I have only one variable, which is x, right? So we need to calculate the same properties like mean and the variance, right? So let's say if I have x and x1 as my input variables, then we need to find the variance matrix. I mean, the variance matrix will be all combinations of x and x1, right? So based on that, we can obviously say what I mean to say is, so here what we did, I have two classes, right? Sorry, I have only one variable, right? So for that variable, I find the variance when y equal to 1 and y equal to 0. In similarly, I have to find for the other variables also, right? So now this variance is for x1, sorry, variable x when y equal to 1. In similarly, if I have x1, I need to find the variance of x1 when y equal to 1, and then I need to take the average of this and I need to substitute those values in this formula, right? So here we have two classes, right? So 0 and 1. Let's say if I have 0, 1 and 2, then we'll have one more here, like it will be 2, right? And also I need to find the probability when y equal to 2, right? So hope you enjoyed this video. So in our upcoming videos, we'll talk about the decision trees, right? The tree based algorithms. So till then, please don't forget to subscribe to my channel. Thank you.